So welcome back. In this video, we will be discussing the disinfection aspects of water treatment and particularly the different forms of chlorine application and the kinetics of chlorination. General forms of chlorine application in water treatment is it can be a bleaching powder, it's a calcium hypochlorite, and 30 to 33% of chlorine is available. It is extensively used but not stable, but it loses its strength upon exposing to air. So safe storage is required. Use it for small installations and for small applications, particularly in during rainy season. So this bleaching powder is dumped in the open wells. So such type of things only we are going to use this. Sodium hypochlorite is also used. Some other commercial products are also available, but predominantly bleaching powder is the common usage. It is a white powder. Chlorine gas, it may be fed directly to the point of application to the water supply, and gas may be dissolved in a small quantity of water. Then the solution is fed to the water. And an equipment is used is called the chlorinator. You can see chlorine glass is there, and the gas is allowed through, and how this measurement is there. And then this is mixed with water, and then that entire water is dumped into the treatment system. Chlorine in the form of liquid is also used. It is 1.44 times heavier than the water. It is stored in a liquid form, and chlorine is kept under the pressure of 7 kg per centimeter square. So it's available in the form of cylinders. You can see here. It is a yellow colored chlorine liquid. It is highly corrosive and is provided with special fittings. Chlorine tablets. So this is another one which is normally used under epidemic situations. The chlorine is available in specific dosages uh, in the form of tablets. So you take water and then you can add 1 or 2 tablets into this water and then wait for some time for the contact time. After that, you are able to drink. So you see here, filter, we take the water, dirty water filtered, and then add, this is normal situation, and this is rainy period. Dirty water is removed, and add chlorine 2 tablets, and then drink it. The factors affecting chlorination, some of the parameters. Turbidity, because of turbidity, what will happen? The penetration of chlorine through turbid water is difficult, hence filtration and coagulation are essential before disinfection. Presence of metallic compounds. Metallic compounds such as iron and manganese, they consume chlorine to oxidize. So during breakpoint chlorination, we understood that the oxidization of inorganic compounds are also possible. If chlorine is added, some part of it is not consumed by these metallic compounds. Lesser is their presence, higher is the efficiency. Contact time. Sufficient contact time is necessary between chlorine and microorganisms. Usually 10 to 20 minutes is preferred. Temperature of this water. Lesser the temperature, less will be the efficiency of killing. And nature and concentration of microorganisms. Different contact times are usually employed for destruction of bacteria. pH, we already noticed this pH is again important parameter in terms of HOCl and OCl minus formation. HOCl is more effective, so lower pH, that is around 7 to 8 pH is more effective in the disinfection process. Ammonia compounds. Chlorine converts ammonia to chloramine compounds. Ammonia without organic matter may form combined available chlorine, which is not effective as free available chlorine. Higher quantity of combined available chlorine gives similar efficiency as that of free available chlorine. Sufficient amount of chlorine should be added if ammonia is resent to the water. Now let us see the kinetics, how with respect to time and temperature, how this disinfection process is going to change. The time of contact is the most important thing every time we are talking, 10 to 20 minutes, etc. So this is estimated based on the Chick's law. It says that ln of n by n naught is equal to minus kt, or n is equal to n naught e to the power of minus kt, where n naught is initial value of microorganisms, n is nothing but the number of microorganisms remaining at a time t minutes. K is the rate constant per minute, and t is the time of contact. If 90% removal is taken, n by 90, n by n naught is equal to 100 by minus 90%, which is equal to 0.1 is remaining. 10% is nothing but 0.1 decimal point of view. And kt is equal to 1 if you take n by n naught is equal to 0.368, that's 6.8%. So it depends on how much removal we are targeting, and what is the rate constant, how the reaction is progressing, and this is important. And if you know the contact time, accordingly we are going to calculate the removal efficiency of the microorganisms. Concentration of disinfectant, C to the power of n, the T to the power of Tp is equal to constant. C is equal to concentration of disinfectant, and T is the contact time required to affect a constant percentage of kill, and n is an empirical constant. Normally n is equal to 0.86. It indicates time of contact is more important than dosage. The value varies for each microorganism. N value will be varying for different microorganisms here. So using this information also, how much should be the concentration of disinfectant for specific microorganisms we can calculate. Concentration of microorganisms. So here C is the concentration of disinfectant, NP is the concentration of organism that is reduced by given percentage in given time. So using this information, we can calculate this empirical equation. Temperature is again an important parameter. So log 10 T1 by T2 is equal to E T2 minus T1 by 2.303 or T1 T2. T1, the small T1 T2 are time per given percentage kill at temperatures T1 and T2 in terms of Kelvin, and E is the activation energy, and R is equal to gas constant. Let us quickly look at two small problems with regard to the kinetics. It is designed to obtain 95% kill of microorganisms. Estimate the time required assuming rate constant as 0.2 per minute. So you go with the Chick's law, n by n naught is equal to e to the power of minus kt. 95% kill means remaining is only 5%, that is equal to 0.05, is equal to n by n naught. So k is given here 0.2 minutes per 2 per minute, and substitute here and then calculate the value of t, 15 minutes. So that means the meaning here is when the reaction rate is progressing at 0.2 per minute, to achieve 95% of kill, you require a contact time of 15 minutes. If the contact time is 20 minutes for disinfection, determine the percentage kill that can be obtained assuming rate constant as 0.1. Rate constant is low, slightly lower here compared to the previous problem. 20 minutes contact time is given. So how much is the percentage kill? Again, we are using same equation, n by n naught is equal to e to the power of minus kt. K is given 0.1 and T is given 20 minutes. N by n naught we have to find out. N by n naught is equal to 0.14. So what is remaining? 100 minus this. So that is 86% is the destroy. And this is another calculation we use in the practical problems. Obtaining this temperature, the contact time and then based on that, deciding the contact tank. Now, what you are going to see, you can see from this figure, the filtered water is coming from the treatment system, and the chlorine, what are the solution you're preparing, you are there in one particular tank, and this is now added through a dosage meter, and these two are now combined for a contact time. And this is where the contact tank, the volume of the contact tank is important. For finding out this volume, we need to know how much should be the contact time, and based on that, what should be the volume of the tank. Uh, That's how you are going to calculate. After this, this water is now sent to further step of distributions. The water sample is to be disinfected with 35 milligram per liter of chlorine to obtain 99% kill of microorganisms. The number of microorganisms remaining active is modeled by NT is equal to N naught e to the power of minus KT. The water flow rate is 36 meter cube per hour, and K is given as 0.23 per minute. If the depth and width of the chlorination tank are 1.5 meters and 1 meter, compute the length of the tank. Here, what we have to find out, the first step, for 99% kill of microorganisms and a rate constant of 0.23, we should find out what should be the contact time. Then flow rate is given, then contact time you have found out. Based on that, we can calculate the volume. Volume is nothing but LBH, width and depth are given, and L we can calculate from the relation of volume. Same thing I'm obtaining here. 99% removal means 0.01 remaining. K is equal to 0.23. Now I'm calculating T is equal to 20 minutes from the Chick's law. Water flow rate is 36 meter cube per hour. Now we're converting into meter per minute. So volume of the tank is equal to discharge multiplied by contact time, 12 meter cube. The width of the tank is known, depth of the tank is known, and the length is nothing but volume divided by B to H, which is equal to 8 meters. So here it is a cylindrical tank is given, but instead if you go for a rectangular tank, and this is how you are going to obtain the dimensions.